What if everything we've ever known, every star, every planet, every galaxy isn't floating freely in space, but is instead trapped inside something else? Something so dense, so powerful, so mysterious that even light cannot escape it. It sounds like science fiction, but growing evidence, strange math, and mind-bending theories are leading some scientists to ask a terrifying and fascinating question. Is our entire universe inside a black hole? It's not just a clickbait question. This theory is rooted in real physics, backed by equations, and debated by top cosmologists. To understand how this could even be possible, we have to first step into the darkness, literally, to the heart of a black hole. A black hole is what happens when matter is compressed beyond imagination. A dying, massive star collapses under its own gravity, shrinking to a single point. What physicists call a singularity surrounded by a boundary called the event horizon. Nothing, not even light, can escape this region. Time slows. Space warps. The laws of physics as we know them begin to break. But here's where things get weird. In 2010, physicist Nikodem Popławski published a series of papers proposing something radical. That black holes aren't just destructive but also potential gateways. According to his model, known as the Einstein Cartan theory, the extreme conditions inside a black hole could give rise to a baby universe on the other side of the singularity. In this view, black holes aren't just devourers, they're cosmic wombs. And it gets wilder. Popławski went on to suggest that our own universe might be the interior of such a black hole born inside a parent universe. In this model, what we see as the Big Bang wasn't the beginning of everything, but the rebirth of a previous cosmic structure collapsing into a black hole. Let's pause. That's a lot to take in, but the physics supports the idea more than you might expect. According to general relativity, the interior of a black hole is incredibly similar mathematically to an expanding universe. Some equations describing the early universe's inflation mirror the ones governing what happens inside the event horizon of a rotating black hole, called a Kerr black hole. This leads to a startling idea. The Big Bang singularity may have been the inside of a black hole. Bang wasn't an explosion in empty space. Was the rapid expansion of space itself inside that black hole. But is there any proof for this? Any observational evidence? Let's talk about cosmic background radiation, the faint afterglow of the Big Bang. It's almost perfectly uniform, but it has tiny fluctuations. These fluctuations seeded galaxies and structure in the universe. The model of the universe-in-city black hole suggests these fluctuations might come from quantum effects during the black hole formation in a parent universe. Essentially, the randomness we see in the universe today could be inherited from another, older cosmos. And then there's the shape of the universe. If our universe were inside a black hole, you'd expect it to be closed or finite. Observations from the Planck satellite have shown hints that our universe might indeed be slightly closed. Though the data isn't conclusive, it's just one more piece that aligns with the theory. Now, consider time. In general relativity, time behaves strangely near massive objects. Near a black hole, time slows. From an outside perspective, an object falling into a black hole appears to freeze at the event horizon. But from the inside, time proceeds as usual. If we are inside a black hole, that could explain why we see time flowing forward, while the rest of the multiverse might see us frozen. There's also entropy, the measure of disorder. Our universe started in an extremely low entropy state and is moving toward high entropy. This arrow of time is one of the biggest mysteries in physics. Some theorists believe that the collapse of matter into a black hole, followed by a Big Bang-like expansion inside it, may offer a natural explanation for this direction of time. Still not convinced? Let's talk about information. Stephen Hawking's black hole information paradox asked, if black holes destroy information, what happens to quantum states that fall into them? Popławski's model offers a beautiful solution. The information isn't lost, it has transferred into a new universe. In other words, universes could be born inside black holes, carrying forward the information of the parent universe in new and unpredictable ways. Now let's consider the multiverse. In traditional cosmology, the multiverse is a hypothetical collection of other universes beyond our own, born from quantum fluctuations or infinite inflation. But in the black hole model, the multiverse is very real. Each black hole in any universe could be spawning new baby universes, including ours. Every black hole could be the seed of a cosmos, and we might be one of them. But if we are inside a black hole, how could we ever know? That's the hardest part. By definition, nothing can escape a black hole, not even information from inside our universe. We can't observe what's outside the event horizon, if one even exists. The black hole's boundary would appear to us like the cosmic horizon, the furthest edge of the visible universe. We could never see the parent universe, just as we can't see beyond the event horizon of any black hole. Yet the math still works. The geometry of a black hole's interior, under the Kerr model, closely matches the geometry of our universe's expansion. Some physicists suggest that the early inflation period of our universe, when space expanded faster than the speed of light, could be explained by the violent conditions of black hole formation on the other side of the horizon. So where does this leave us? Are we doomed to remain inside, unaware of the larger cosmos we're inside of? Or is this idea just another untestable theory, beautiful, but ultimately unverifiable? Well, not everyone agrees. Critics of the theory argue that while the math is intriguing, we lack direct observational evidence. Others say it's more philosophical than scientific, since it may not yield falsifiable predictions. But that hasn't stopped the theory from gaining traction. Astrophysicist George Smoot, who won a Nobel Prize for measuring the cosmic background radiation, has expressed interest in the idea. He once said, "It might be crazy, but it might be right." And in theoretical physics, that's sometimes the line between breakthrough and insanity. Even Stephen Hawking, late in his life, began exploring the idea that black holes may be more than just the end. He proposed that information escapes through quantum tunneling, and that black holes may link to other universes, just not in a way we can currently observe. But perhaps the most poetic part of this theory is what it says about creation. If we're inside a black hole, then we are part of an unending cycle of birth, death, and rebirth across the multiverse. Every time a star dies and collapses, a new universe could be born. Maybe black holes aren't the end, they're beginnings. Maybe destruction is the price of creation. And maybe, just maybe, life finds a way to exist again and again. So next time you look up at the stars, realize this. The entire sky you see could be the inside wall of a cosmic tunnel stretching, not into space, but into something far deeper. We might be in a dark cradle, born from collapse, expanding through time, and heading toward a fate we still barely comprehend. In the end, whether our universe is inside a black hole may remain a mystery. But the theory forces us to think bigger too, accept that the universe might be far more complex, more alive, and more connected than we ever imagined. And as always, science doesn't claim to have all the answers. It gives us the tools to ask better questions, to explore, to wonder, and maybe, one day, to understand. If that journey into the deepest corners of the cosmos fascinated you, don't forget to like this video, subscribe to Beyond Stars, and tap the bell icon so you never miss our next dive into the unknown. The universe might be inside a black hole, but your curiosity is limitless. Thanks for watching.